Hello, everyone. Welcome back. Today, we are going to explore one of the most fascinating topics in technology, quantum computing. You may have heard that it's the future of computing, but what does that actually mean? How is it different from the computers we use today? And why is the whole world so excited about it? Stay tuned, because I'm going to break it down in simple words. Have you ever been inside a huge library, so big that it seems endless? Imagine rows and rows of books, billions of them, stretching as far as your eyes can see. Now, let's say you want to find the answer to one single question hidden in one of those books. A normal computer is like a person searching through that library, opening one book at a time, checking each page patiently, and then moving to the next. It will eventually find the answer, but it takes a lot of time. Now imagine if you had a team of magical helpers. Each one could open many books at once, check them together, and instantly tell you where the answer is. That's the kind of power a quantum computer has compared to our normal computers. It doesn't just search one path at a time, it explores many paths all at once. To understand how this magic works, let's start with how ordinary computers think. Every computer in the world, from the one in your phone to the one sending rockets into space, speaks the language of bits. A bit is like a tiny switch. It can be either off, we call that 0, or on, we call that 1. It's as simple as a light bulb. It's either glowing or it's not. By combining billions of these bits, computers can do calculations, show you videos, or let you play games. But no matter how powerful they are still limited because they only deal with one state at a time, on or off, 0 or 1. Quantum computers, however, use something far more interesting: qubits. A qubit is like a magical coin. When you toss a coin in the air while it's spinning, it isn't just heads or tails, it's kind of both at the same time. Only when it lands do you see the result. That both at once state is called superposition, and qubits live in that world. Because of this, instead of checking one answer at a time like bits do, qubits can check many possibilities together, like peeking into lots of books in the library at once. But the magic doesn't stop there. There's another superpower qubits have, called entanglement. Imagine you and your best friend each have a pair of magic dice. You keep one die, and your friend takes the other far away, maybe to another city or even the moon. Now, no matter how far apart you are, whenever you roll your friend's die will instantly show the same number. If yours shows a 3, theirs shows a 3 too, as if the two dice are secretly connected by an invisible thread. That's what entanglement is, when two qubits are linked so strongly that changing one instantly changes the other. This ability makes quantum computers incredibly powerful. While normal computers need to go step by step through calculations, quantum computers can use superposition and entanglement to look at many answers together, sharing information instantly between qubits like a perfectly synchronized team. It's almost like they're solving puzzles by working in harmony rather than alone. So what can we do with such magical machines? Well, the possibilities are enormous. Scientists dream of using quantum computers to design new medicines by simulating molecules in ways that classical computers could never manage. Imagine discovering a cure for diseases much faster because the computer can test millions of combinations in seconds. They could also help us build better batteries, making our electric cars run longer and our phones last days instead of hours. They might even make ultra-secure codes that are impossible for hackers to break, keeping our data safer. Some researchers believe quantum computers could help predict weather with far greater accuracy, or even help us understand the mysteries of space. It almost sounds like science fiction, right? But here's the twist. Building a quantum computer is not easy. In fact, it's one of the hardest challenges scientists face today. Qubits are delicate. Imagine them like soap bubbles. If you touch them, or if the room is a little too warm, or even if there's a tiny vibration, pop, the bubble bursts, and the qubit loses its magic state. To protect them, scientists build quantum computers in special labs where the temperature is colder than outer space. Even then, they're still fragile, and keeping them stable long enough to solve big problems is a huge challenge. But despite these difficulties, progress is being made every day. Companies and researchers around the world are racing to make quantum computers more reliable and powerful. They believe that, just like electricity changed our world, and just like the internet connected us all, quantum computers will one day bring a new revolution in how we solve problems. And maybe the most exciting part is this: quantum computers are still young. We're only at the very beginning of this journey. The scientists working on them today are like the early inventors of airplanes, experimenting, failing, trying again, and slowly getting closer to something that will one day change the way humans live. So the next time you open your laptop or play on your phone, remember, those machines are powerful, but there's something even more magical on the horizon. Quantum computers are like wizards waiting to show us new worlds of possibility. Who knows? Maybe one day you will grow up to be the scientist who builds one, the dreamer who unlocks their secrets, or the explorer who uses them to solve mysteries we can't even imagine today. So that's a quick introduction to quantum computing, a technology that could change everything from medicine to cybersecurity. What do you think? Will quantum computers replace classical computers in our lifetime? Let me know in the comments below. If you enjoyed this video, don't forget to like, share, and subscribe for more easy tech explainers. Thanks for watching, and I'll see you in the next video.